Thank you, and good morning, good afternoon, and good evening, everyone. Welcome to our talk on phishing bots. My name is Pedro Fortuna. I'm founder and CTO at JScrambler, and I've basically been working in security for almost 2 decades. In the last 8 years or so, I acquired the bad habit of giving talks. This is actually my second time speaking at AppSec USA. It's a great pleasure to be back.
Hi all, I'm Jasvir Nagra. Most people call me Jazz. You should too. I'm an author, a builder, a writer. It's been a while. I think I've caught Pedro's bug giving talks again. This is the second talk that I'm giving along with Pedro in as many months. It's addictive. It's really great to see you all.
So we want to start by talking about how bot writers can hurt you.
So this is a tough but interesting question, Pedro. There are many good reasons to automate access to a website or to a web application. But there are also ways in which letting bots abuse your web application results in damage to you, right? Like a former coworker of mine, I think it was a Gertrude Stein quote that he's abusing. He used to say, a bot is a bot is a bot. And what he meant by that is, you know, no matter what happens, a bot is just a bot. And I think that that's not quite true, right? Some bots are good. They increase your value. There are others which are questionable. If you're not quite ready for them, they can hurt you. Yet others are clearly bad for you and for your business. And I think that what we need to do is to classify bots into categories depending on what they're trying to achieve. And that helps us defend against them a little bit better. We've roughly come up with 4 major categories depending on what a bot is trying to achieve. One of the things that you'll notice when we go through these categories is that it happens to line up not only with how hard it is to build this kind of bot, but also how much value the bot ends up getting, which is really a nice characteristic, right? The more value a bot writer wants to get, the harder it is for them to build this kind of a bot. Pedro, maybe you want to lead us through these categories.
Sure, Jazz. So most of the audience should already be familiar with these categories. So I'll quickly skim through them, starting with scraping bots. You may argue that this is not a bad use for bots, and in some cases, indeed, it can be beneficial, as it can bring more traffic and users to your website. But in many other cases, it can actually result in business losses, and as such, something that businesses want to prevent. Bots are also used to DOS competitors or adversaries by triggering expensive operations. These bots are undeniably bad and should be stopped before they stop companies from offering their services online. But I think Jazz has a funny episode he experienced. Jazz, maybe you can tell the Google bot episode here.
I sure can. This is a simple story and one that many of you in some variation would be familiar with. So I mentioned some bots are good and desirable and some bots are bad and cause like load on our servers. That might make you think that, oh, I can just classify these are good bots and these are bad bots. But sometimes there's like a little bit of confusion there. In this particular case, the case that I'm thinking of, there was a Google bot that would cause this customer that was selling hardware to search for a particular item. And it turns out it was searching for a particular small screw. And every time the Google bot would come by, it would trigger via URL this search for this small screw. It turns out this particular customer sold 20,000 different kinds of small screws. And so every time the Google bot would come, it would cause the database to move 20,000 entries out of the database into the local cache. And so the Google bot was whitelisted by the marketing team because, you know, the marketing team believes that the Google bot is a good bot. You want to be ranked highly on the search results. For the infrastructure team, however, maybe they should have tuned their database better, but like every time the Google bot would come by, it would cause like the database to instantly melt because they were moving this large quantity of data out of the database into the local cache, right? Not only that, because every time the prices would change, the Google bot would visit them more and more frequently, which caused them to melt down, systematically a couple of times a day, and all of them were tearing their hair out because they had no idea. The lesson to take away is that it's not necessarily the case that there's good bots and bad bots. There's good behavior and bad behavior. What is a advantage to one part of your company might be a headache to a different part of your company.
Right. So you have to watch out for good bots too. They might hurt you. Bots are also extensively used to buy or hold inventory, like booking tables, reserving airline tickets, usually for a good profit. In some cases, like airliners, the ticket reservation system does not force the bot master to actually buy the tickets. So if they cannot resell them for some reason, they can release them last minute, which causes those tickets not to be sold at all. In some situations that we learned about, airliners had full flights turn into almost empty flights last minute, and that would generate a lot of losses for them. It can also damage reputation if legitimate users have harder time acquiring tickets or products, or end up having to pay unreasonable prices for them. And last but not least, let's talk about credential stuffing. This particular use of bots is known by different names. For instance, it's also referred to as account takeover bots. And typically, attackers buy breached databases from the dark web full of credentials, and then use a bot to test those credentials on another site. And because a lot of people reuse passwords, they can actually find and take over a few accounts on this different website. There's also a special case of this where instead of relying on spilled passwords, a phishing attack to potential users is done to capture their credentials and then control their accounts. This will actually be the focus of this talk. So we'll see plenty more about this later on.
But before we dig into the problem itself, there's a lot of techniques that historically have been used primarily by server-side agents that are traditionally used to detect bots. And many of these are going to be techniques that you're going to be familiar with. So I'm just going to blaze through these. Mostly they involve detecting the environment or the test harness that the bot writer is using to connect to your real site, right? Maybe there are how often this particular client is connecting, or maybe some abuse that the bot is carrying out that you are able to determine. In order to defend against these, it's a trade-off between how expensive these techniques make it for the bot writer versus how expensive it is to deploy these. The most obvious one that you probably all know of is IP reputation. So this is the most basic technique. It's the obvious thing that would occur to you, right? Like it is to assume that the attacker owns one or maybe a small number of IP addresses that they use to carry out this attack. If this is true, then you can assign to an IP address a reputation, and you build up a database. When was the last time this IP was used to carry out undesirable activity? And then if you later on see one of these bad IP addresses, or even groups of IP addresses, these are called ASNs, which is what a provider of an IP address does, loosely speaking. Then what we can do is we can blacklist the IP, or we can blacklist the entire ASN. Now, unfortunately, a simple common shortcoming of this approach, which used to be very effective previously, is that attackers are able to entice users using browser extensions or proxies or VPNs or free apps to happily give up their IP addresses. And then these IP addresses, which belong to individual users, to residential users, they act as proxies to clean up the IP reputation that is being used to connect to a site. The other thing that you might be able to do is to throttle requests, right? So if there are many requests coming from the same IP address, maybe more than can be generated by a single user, well, clearly that's a bot. There's two problems that you run into with this. One is that, once again, an attacker has a large number of IP addresses to choose from. They can choose the style of attack called low and slow attack, where they use an IP address only once or twice, and then they just never use them again because they've got such a large pool of IP addresses to choose from. What is more, you can accidentally end up blocking legitimate users because they're using a NAT, or for some other reason they're sharing an address, right? Like, so universities or businesses often have a single IP address going out, and the small number of IPv4 addresses that are available makes this problem worse, where you end up, because 2 or 3 people happen to be booking something that was using the same NAT, you suddenly say, oh no, this entire subnet, this entire NATed address is probably bad. And so throttling has strengths and weaknesses there. The other technique that would occur to you, which is the obvious one, right? Like, it's the most famous, the most notorious way of detecting a bot is using something called capture. Now, I don't need to tell you, or indeed anybody else on the internet, what this is. You get to see this all of the time. What you do is you get you present a task that is easy for a human to perform, but is like very difficult for a computer to perform. And that way, you can force at least there to be a human behind the computer that is doing that is doing the task, right? Now, it's worth saying here that there's subtly different approaches that are being used. Capture is not a static field; it's an evolving one. One of the techniques that is used is called invisible capture, where the subtle differences between how bots behave, for example, how bots move a mouse, or how they interact with the site, how they type characters, can be used to distinguish them from human beings. And reCAPTCHA famously uses one of these techniques. That's not the only technique that is being used. Cloudflare, for example, has a proposal called the cryptographic attestation of personhood, which is also trying to minimize the number of cases where you are forcing a human being to do something, because these captures are very annoying. I mean, as computers have become better, as machine learning has become better, the work that a computer is able to do becomes increasingly similar to what a human is able to do. Now, the shortcoming here is that as long as you can farm out the capture process itself to countries where it is cheaper to get human beings, like real human beings, to do the task, you can sort of split the application into the actual application and the capture solving, and solve the capture that way using a real human being. The other thing that is being regularly used is reverse engineering, where you reverse engineer what it is that the capture is doing. The next technique that is used is device fingerprinting. This is the obvious thing where that this user, most users have a small number of devices. You cookie the browser that the user uses, and then if the user is coming with a different browser or doesn't have this particular cookie, you can determine the characteristics of the browser and the version, and you can dig deeper if this is a known user, but using a different kind of browser, and you can work out like, hey, this is unusual for Pedro to be connecting not from Portugal. He's suddenly connecting from Fiji. Oh, you know, something is weird here. Or he's regularly a Firefox user, but suddenly is using Safari. You know, something is unusual here. And what you can do is you can fingerprint the device. You can figure out what is the OS that this user is running. What are the fonts that are on this particular computer? The shortcoming of this approach is obvious, right? It's the privacy concerns. What you as the real site are trying to work out is, hey, is this a bot that I have seen before that is trying to evade me by like deleting the cookies, etc. But what you end up learning is who this exact user is, and that's, you know, there's legitimate privacy concerns from fingerprinting a browser, and it's something that browsers are trying to get rid of, rightfully so. So privacy concerns are one. The other is that when you build up this package that says this is the fingerprint, you can still reverse engineer this fingerprint, and then if a attacker is able to do that, they can create a new fingerprint that that tells the lie that the attacker is trying to create. The last and most commonly repeated story on how to defend against phishing is 2FA. Now, 2FA is a large umbrella term that lumps together all kinds of things. As you'll see in a moment, when Pedro gets going, we tend to talk about 2FA. You know, there's like SMS, which is your second factor. There's, you know, these authenticator apps that generate an ID. There's hardware keys. We tend to lump them together, but some of these are better than others. And one of the things that you will walk away from this presentation realizing is that hardware tokens do a very good job at preventing this kind of phishing attacks that we're going to be talking about. But their penetration in the market is very small. And so in the meantime, there's a large need to be able to support users that don't necessarily have hardware tokens. And if you have, you know, SMS type tokens, or even Google Authenticator tokens, there's a set of phishing attacks that are live that end up being very effective in spite of rolling out 2FA. Basically, an attacker is able to proxy your 2FA very effectively. So I'm going to talk about one specific problem, which is the phishing bot problem. Now, I'll tell you why I'm talking about this particular problem. It's the hardest version. And I guess I'm a masochist, and so is Pedro. And so we're trying to tackle what is the hardest version of this problem, assuming that if we can solve this hard version of the problem, then all the other problems, you know, sort of become much more easily accessible. So, you can think of this phishing bot problem as a special case of the credential stuffing problem. But the credential stuffing problem is, you know, you find spilled passwords and then you try to like reuse them. In the phishing bot problem, the entire attack has to be live because the site is carrying out all kinds of defenses to make sure that, you know, 2FA is provided. Next slide, Pedro. So what is a phishing attack? A phishing attack is an automated attack. It lures, phishing lure. It lures an unsuspecting user to a fake site to steal their credentials, their personal data, or to carry out transactions on their behalf. This works by setting up something, a fake site, which is sometimes called a web fake. This is the phrase that I'm going to be using. What is a web fake? It is a copycat website, which is sometimes hosted on a similar looking domain. So you might have virtualbank.com, which is your real bank, and v1bank.com, which is, you know, the fake site. And what you want to do is to entice the user to visit your fake site and then carry out the attack that way. So these attacks are not new, right? They have been happening for ages. What has changed is because we've become so much better with 2FA with defenses against batch attacks. We haven't solved them, but we have become better. These attacks have diversified. They're now coming through all sorts of, the distribution is coming through all sorts of social networks like Facebook and LinkedIn and Instagram, but they also materialize as browser extensions. Users install them expecting to get, VPN access or, some grammar corrector or something. But in addition to doing the thing that makes the user happy, the site is also, the extension is also grabbing and changing what a user sees when they visit a variety of sites. So less savvy users inhabit these networks. They install these extensions because they don't know better. I say less savvy users. I certainly have been pretty close to being vulnerable to this as well, and I consider myself a pretty savvy user. And so I think, all users are pretty vulnerable to this style of attack. As a defender, from a defender's perspective, we have to assume that some chunk of our users, it might not be large, it might not be small, but some chunk of our users are going to be falling for this particular style of attack. But what does this attack look like? Well, in the standard case, you go to the virtual bank site. This is the front end. You type in your username and your password, and you send it to the API. It gets verified, and what gets sent back is an authorization token, maybe a signed JWT token. I believe those are called JOT. I still have difficulty pronouncing that. Now, every time you need to carry out a transaction thereafter, this is the token that you provide, and now everything is happy. We know that you are authorized to access this. Now, if you can trick a user into going to this web fake version, a copycat version, the user provides their credentials. The fake site may even go back to the actual API, to the real site API, present these tokens, get a signed JOT token back. And now the fake site can act as you and proxy everything. Now, one of the first things that people realize when they see something like this, they're like, hey, I'm just going to roll out CORS. What does CORS do? CORS makes sure that my API can only talk to my front end. But this doesn't quite work because the web fake version is in control of where the connection is made to. They can connect to a proxy that does a variety of things. It can strip out the CORS header. It can rewrite the CORS header. It can make sure that in spite of all kinds of defenses that the API is trying to provide, those defenses are pulled out. What about 2FA? Well, 2FA does help, but it cannot help in situations because where the user thinks that they are driving, they are expecting the 2FA prompt. They've gone to the site says, hey, I'm about to send you a 2FA. It ends up connecting to the API. The API calls out, sends the 2FA, whatever the 2FA is. The user is expecting it. The user types in the 2FA to the third-party site. This is the live attack. The web fake version takes the 2FA that the user provided, the legitimate 2FA, sends it to the API, and authenticates it. One of the defenses, and this is why I talk a little bit about YubiKeys and other hardware keys. A hardware key is in a position to check, hey, is this actually the site that I wanted to type to provide my secret to? Or maybe the secret is encrypted using the domain that you are on. Now, in that particular case, yes, it does help. But these hardware tokens, these hardware keys, whilst increasing in numbers, are a very small amount of the general usage that most websites see. And it would be interesting to see also how much value and how much usability we can provide using these hardware keys. But like I say, 2FA is where you type in your username, where you type in a secret, very different from a hardware key that automatically authenticates. Now, I'm just going to pause for a second and say, why do we care? There are many reasons why we may care, right? Why I care and why you probably care. Like, one is that this attack affects any website. It can be automated, therefore it can scale. It's very easy to implement, and the ROI for attackers is very high. You basically get control of your users' accounts. And this has been a real problem for ages. It's becoming a worse problem over time, but it has been a problem for a long time. The reason I care, and I think why Pedro cares, is because this attack is not talked about nearly as much as it should. It's a pretty common attack. It's a very hard problem, and therefore an interesting security problem as well. And I'm attracted to interesting, hard security problems that are prevalent. And I think that you should be excited about problems of this style as well. Now, before we get knee deep into what the solution is, it's important to understand what exactly needs fixed. To frame the problem well from a technical standpoint, first of all, let me tell you all of the things that this is not. This is not a traditional API security problem. This is not about finding and fixing typical API vulnerabilities. This is not, find an XSS. This is not find a CSRF problem. This is not an authentication problem, not even a 2FA problem, because this proxy is able to bypass a large amount of the solutions that you may roll out. It's also not a good fit for API abuse. In this particular case, the API is not really being abused. For every one of the cases, for every one of the users, you probably only get one connection, one attempt. It's not a denial of service attack. It's not the goal of the attack for the attacker to do credential stuffing, to try all kinds of different passwords. This is a phishing problem. And if you think about it, like, most phishing problems are not a problem that can be easily solved, not without forcing everyone to have a hardware key of some kind. But to date, that's not universal, and as will become clear in a moment, even if you have a hardware key, it's not obvious that that fixes all of the problems. Nevertheless, we have high hopes for WebAuthn becoming more popular. But for now, we cannot get rid of phishing. We have to deal with the consequences that arise. So in our perspective, this is an automated attack problem. It needs to be stopped with automated attack prevention techniques. Basically detecting and preventing bots. One of the things that we're going to talk about is code protection in particular, and it's going to become clear why that approach systematically helps mitigate this particular attack. Let me show you a demo of what the attack actually looks like. Okay, let's set up this demo. It's a little subtle because there's several things going on, but it's easy to follow along. We have a real API running on port 4000 right on the top window of the tree. We have the real front end being served on the second window on port 3000. And then because we have to do this, we have a fake website running on port 5000 on the third window. Now, you go to the legitimate site, you go to virtualbank.com, you type in your username and your password, you log in, woohoo, you're logged in. And if you go to the drop server, which is where the passwords will accumulate, you see that there's no password being leaked because, of course, this is the legitimate site. Okay. Instead, what we do is if we load up the v1virtualbank.com, you know that this is evil because it has the evil pink background. The user has been convinced to type in their username and password. When they log in now, we're proxying the entire site so they can see all of the things that they would see on a real site. But in addition, if you go to the drop server, we're also exfiltrating the test username and test password, which means that the attacker can now go ahead, change the contact address, for example. In this particular case, the attacker is doing this manually, but the attacker can do this automatically and change the contact address. And now this is an account takeover. The attacker is completely in control of this particular account. You can see on the top window, the actual site is receiving the real login password and maybe 2FA credentials. The takeaway that you should have here is this is a real problem. It's not been given the attention that it deserves. There aren't any numbers on the size of this problem, and so why should you believe me? We know you should believe me because the problem is really easy. It's really cheap. In fact, over the last week is when Pedro and I put the demo together. It took us, a couple of days. When I say us, I mean Pedro. A couple of days to put this to put the attack together. We know it's easy. We know it's cheap. It scales well. It provides great ROI for attackers. It should be considered a threat model for any transactional website which takes the security of its user data seriously, which is all real websites, right? Now, we did not paint this terrible picture for you just to leave you stranded. We'll provide a strategy and some insights on how you go about mitigating an attack like this.
Yeah, we'll give you some hints on how to give the attacker the boot. So let's talk about the attacker's mom. No, I'm not trying to be juvenile here. MOM is the acronym that results from method, opportunity, and motive. So this is a relatively known model in security that represents three things that influence the likelihood of a successful attack playing out. So method represents how skillful the attacker needs to be and what tools and knowledge the attacker needs to have. Opportunity represents the existence of a window of attack and its duration. And finally, motive represents the motivation of the attack of the attacker. Usually we are talking about the ROI, but can also be non-financial, like tied to reputation, politics, fun, etc. So in the figure to the right, you can see all three, each represented with an axis. The opportunity grows with the size of the attack window and duration. The method grows inversely to the skills needed by the attacker. And motive essentially grows with the ROI obtained by the attacker. So as defenders, we want the attacker's mom to be as close to 000 as possible. But let's explore this in the context of our attack scenario. Let's think how we can move the scenario closer to the 000. For method, we can put up stronger defenses, forcing the attacker to go to the next level. If we are lucky, perhaps the attackers will be over their heads, causing them to quit. In opportunity, because this is a phishing attack, there's not much we can do to kill the opportunity. Of course, this should not be an excuse not to promote awareness, but most likely the attacker will still gather a pretty good batch of victims. And finally, the motive is the one where we should put most of our chips. One thing we can do is drive up the cost of the attack. In fact, if we do a good enough job regarding bringing up the costs, if we bring the ROI to 0, we can kill their motive. And then, even if the attacker has enough opportunity and method, it doesn't matter because the motive isn't there anymore. So the attacker will no longer care. And thus, we can say that the threat becomes mitigated. So to bring the cost higher, we should aim to do three things. We should increase the attack complexity, we should decrease attack scalability, and we should increase the cost of materials, like make the attacker use more servers, for instance. So now, Jazz and I spent quite a bit of time thinking about this attack and what can help mitigate it. And if I had to pick the most important slide of the presentation, this would be a great candidate for that. It summarizes our analysis of the tactical advantages one can have when attacking or defending in a phishing bot attack. The two axes that mostly influence the outcome is how much of the real website the attacker needs to run. So in the far left, the attacker does not load the website at all. It has a web fake, and then that web fake interacts directly with the real website API. Whereas in the far right, the attacker needs to navigate the whole real website, usually with the help of a headless browser. On the vertical axis, we have how much of the real website is actually executed by the real user instead of just by the headless browser. So in the bottom, the real user will never execute the real website code, only the web fake. Whereas in the top, the real user will execute all of the real website code. But I want to make a comment here. In some situations, the real website code is ran just because it was reused to build the web fake. But that counts in regards to this axis as well. So in conclusion, the green square represents the combination where the mitigation is more likely, either by blocking it or by working the attacker's mom. That didn't sound right.
I love this. I love the use of the word mom here, Pedro.
In the red square, the attacker has an edge, probably enjoying of a high ROI from a highly scalable attack. So goal number one that we are setting is we have established the two axes. So let's set the goals. This is goal number one. Make the attacker run the real website front-end code. So when we achieve this, we are basically choosing the terrain where the battlefield will occur. This will give the defender an edge because we can then use browser-based defenses, which wasn't possible when the attacker was connecting directly to the API. And will force the attacker to run a headless browser to minimize the chance of being detected. And this will increase the costs and reduce the attack scalability. So to achieve these, we propose the use of one-time tokens embedded in the website code. So every API request should contain an OTT to authorize it. Otherwise, the API request should be ignored. So in this situation, the attacker needs to load the real websites and try to recover the OTT so that it can connect to the API, so that their connections to the API are honored. So from another perspective, we are tying together the execution of the front-end code with the API authorization. One cannot happen without the other. I can imagine what you're thinking. If you were the attacker, you would now be thinking, how can I grab that OTT from the code, right? So to prevent that situation, so in this situation, the attacker is motivated to minimize the costs, and it will try to grab the OTT as fast as possible and go back to direct API calls. So if we deploy the code like what you're seeing in this picture, certainly that would be very easy. We can see the OTT in clear text. The attacker would duplicate the code and grab the OTT out from the code, and no headless browser would even be necessary. But our goal as a defender is for the attacker to pay the headless browser costs. So what we can do here is by using polymorphic code obfuscation in the code. So polymorphic in the sense that every build will generate entirely different looking code, like variables will take different names, control flow obfuscation decisions will be different. so everything will be different, and the extraction of the reference, the extraction references will be lost, and automation is no longer possible. So and this is significant because now the attack cannot be done, and the attack requires automation to do it, unless the time between deployments are really spread out. So basically, if that's the case, the attacker can basically spend time reverse engineering the code and automate that particular version of the code, and still be left with some time to monetize that work. So luckily, that's easy to fix. All we have to do is rotate the code more often, or just deploy the code more often, and that window of attack will no longer be there. So now we can take this to the extreme by generating at every build multiple, potentially thousands of different versions of the code, and round robin through them, or if you have enough of them, never reuse one. So from the attacker's perspective, this will look like a one-time code. It doesn't matter if the code can be manually reversed, as the fruits of that reversal cannot be used in a timely fashion. So now that we have almost unlimited versions, we can generate one or more OTTs to embed in every single version of the code. This generation can be done during builds or dynamically during the execution of the code. Also, optionally, the OTTs can also be binded to the code, meaning that if we catch them being used with different versions of the code, we should not honor their execution. But now we have the attacker running this code, we should not stop here. There's plenty of other code defenses we can use. I will not go into detail, but I would like to mention a few. We can use tamper proofing, anti-program slicing, anti-code lifting, memory encryption or integrity checks, anti-debugging, emulation detection, detecting reverse engineering tools that can be used, and sabotaging that. There's lots that we can use. So when the attacker cannot use any known automated way of reverse engineering the code because those techniques fail, when the attacker cannot manually reverse engineer the code because it's very short-lived, then we can argue that automating the attack is no longer viable. And in this case, OTT lifting is no longer feasible. Now, the attack can still be viable, but now the attacker is fully cornered into using headless browsers and into facing all the code-based bot defenses. And this, at the very least, increases the cost of the attack tremendously, challenging the attacker's motive. So now that we have the attacker using a headless browser, we can and we should make it go through the most effective bot detection techniques so that we have a good chance of detecting it. I will not go over this because this was already covered by Jaz before, but I will say this. These techniques can also be targeted by attackers who can reverse engineer and automate attacks against the code. And here, code-based defenses also play an important role. So here you can see, let's pull all of this together and revisit our phishing bot attack. So here you can see that every call to the API bears a different OTT. This is the normal flow, not the attack. And now the web fake is driving a bot, headless browser, that basically is sending the right OTTs because the full navigation is being used. But what is important to here is that this green box that you're seeing here is a window of opportunity to throw everything we got to detect and potentially block these bots, from code-based defenses to bot detection techniques. This green window is what we bought. We didn't have this window before at all when we were letting like the bot connect directly to the API, and now we do.
Pedro,
so now,
got 2 minutes to wrap up, please. Thank you.
So now we have a very small demo. So here, I'll just go run through it. You see the obfuscated code is running anti-debugging techniques. And we need to close, and the code is obfuscated. You see one version of the obfuscated code. We can still close that and use the websites. And I'll jump to the bots controlled part. So this script is fed the user credentials after being captured and a valid 2FA. And we'll be able to see these scripts controlling the browser. So that's what we got. We got the attacker to be cornered into using the full navigation using a headless browser. Okay, so let me fast forward to running the bots. This is pretty quick. Okay, you see this is being driven by the bots. Now it's opening the settings page, entering the collected 2FA. This is not visible for the real user. This is all in the back, controlled by the attacker. Okay, and it can successfully attack. Okay, but like I said, this demo, it doesn't include any bot defenses or additional defense techniques. We would need to throw all of that in there. So you remember this slide, the second goal corresponding to the second axis is how much the real website code is actually run by the real user. So why do we want that? To cover more ground. We can learn about the real user device and explore differences to the headless browser device. We can tie security controls to the real user device, and we can further increase the cost and reduce scalability. So I had an example here that I will skip for the sake of time. It's an interesting automated tool to do phishing attacks. Now back to you, Jas.
What is our main takeaway here, right? One is that it's a cheap attack to implement. It's challenging to defend against. We have to target what Pedro has called the attacker's mom. This is a phrase I was not familiar with prior to this presentation. We have to target their methods, their objective, and their motivation. The one thing that I want you to walk away with is this is a cheap attack to implement, and it's challenging to defend against. We have to target, as I say, the mom. Now, historically, bot writers used to use a fake browser. It meant that they never even interacted with your real site, which meant in exchange that you had no chance of catching them. If they never talk to you, you have no chance of catching them. If the attacker, doesn't touch your site, doesn't touch your code, how can you find any signal to detect them? Ironically, forcing the attacker to at least run parts of your real website actually gives the defender a fighting chance. I'm not arguing yet that it is enough, but it is enough to give you something. OTT and code protection, the use of code obfuscation, mixing the defender's code with the real website code in a way that can't be easily separated, forces the attacker to run our code. Now, this may sound like a paradox, but a headless browser running the real website gives us a chance of stopping this bot. What we have argued here is that mitigation is possible. We can make the attack impractical by going after the attacker's mom. We make detection and blocking efficient, force the attacker to bring the attack to a landscape we control, the browser, and make reverse engineering hard. If we do all of the above things, then and then only is this phishing bot problem a problem that we have argued is a big and growing problem, is possible to be tackled. Thank you. We're happy to take questions.